Hey everybody, it's Jason from Code Monkeys and welcome to another Code Monkeys tutorial. Today's video we're going to be discussing how to determine the charge rate for your lithium polymer or LiPo batteries, the different types of charging, and some useful tools that can help you determine the overall voltage of your battery and each individual cell's voltage. So here we have two LiPo batteries. We have a 2-cell 430 milliamp hour battery with a C rating of 30. And we have a 3-cell 5000 milliamp hour battery with a C rating of 50 and a burst rating of 100. And we also have a digital battery capacity checker and a low voltage alarm, both of which can be used to check the overall voltage and each cell's voltage in your battery, which is extremely important information when dealing with these batteries. And if you felt a little bit confused when I was describing the characteristics of these batteries, be sure to first watch the video on the basics of LiPo batteries before continuing to watch this video. Alright, so first of all, whenever handling any LiPo battery or any piece of equipment that is used to charge the battery or check the voltage, be sure to read through the user manuals provided by the company before operating them. So the charge information for your battery can usually be found on the back of the battery, and it can also be found in the user manual. And usually we'll charge your battery at the 1C charge rate, which is 5 amps in the case of the 5000 milliamp hour battery, because the C value is equal to 5000 milliamps, which is equal to 5 amps, and 1 times 5 amps is simply equal to 5 amps. And similarly, the 1C charge rate for the 430 milliamp hour battery is 1 times 0.43 amps, which is equal to 0.43 amps. And you may also be able to charge some batteries at a charge rate of 2C, 5C, or even 10C, but this is not the case for all batteries, so be sure to refer to the battery's user manual before attempting to charge at a higher charge rate. And charging at a higher charge rate will charge the battery faster, but it comes at the cost of decreasing the lifespan of the battery. So generally, the smaller the charge rate you use, the longer the lifespan of the battery will be. So instead of always charging your battery at the maximum safe charging rate, you can charge it at the 1C charge rate or even at a lower charging rate, like for example 0.5C or 0.25C, which should make the battery last even longer. Also, if you are not sure what the charge rate of your battery is, you should always just be able to charge it at the 1C charge rate. Alright, so that sums up what your charge rate for your LiPo batteries is. Now we will discuss the concept of storage charge. So this is the charge you should leave your battery at if you will not be using it for an extended period of time, and it is also the charge that your batteries should be shipped at. So performing a storage charge will bring each of the battery cells to the same voltage, and the storage charge for these batteries can range from 3.7 volts to 3.85 volts for each cell, and usually 3.8 volts per cell is ideal, but anywhere in that range should be fine. But always be sure to read the charging instructions for your battery to obtain the proper storage charge value of each cell. Also, it should be noted that the storage charge value for each cell is at approximately 30% of the cell's total charge. So you may be asking yourself why we need to have a storage charge, and the answer is because the chemicals inside of these batteries deteriorate at a much faster rate when the battery is fully charged or close to fully charged, because the chemicals are in a more reactive state. And if you leave your battery fully charged or close to it when storing the battery, then it can become inflated because the reactions taking place in the battery will release gases, which will make the battery unsafe to use. Also, if you store the battery when it is fully charged, there is more energy stored in it, so if an accident does occur, it is more likely that the battery will catch on fire because the increase in the amount of energy can get released in the form of heat. And similarly, if the battery is fully discharged or just stored below the ideal storage voltage, the chemicals inside the battery will also deteriorate at a much faster rate, which can permanently damage the battery and cause the charger to interpret your battery as dead because the voltage will be too low, which means the battery will be unchargeable. So when storing, charging, and discharging your batteries, it is recommended to store and charge them in a fireproof LiPo safety bag or some type of fireproof container, or at least on a fireproof surface like concrete or ceramic. So be sure to store the battery at the recommended storage charge for safety and to increase the lifespan of your battery. And in the next video, we will demonstrate how to use the storage charge setting on a 4-button charger that has a LiPo battery setting, which will bring each cell into its desired storage voltage range. So that's storage charge. Now we will be discussing the concept of balance charging. So a balance charge is where each cell in the battery has the same voltage, or at least approximately the same voltage, which will prevent irregular current flow and increase the lifespan of the battery. So if your cells have a difference of a few millivolts, then you can consider your battery approximately balanced, but always remember to adhere to the values given by the user manual and try to get the cells as close in voltage as possible. And ideally, you should balance charge your battery every time you charge it to increase the lifespan of your battery. And notice that each of these batteries has a red lead, which is the positive lead, and a black lead, which is the negative lead. That will have, for example, a Dean's connector, a JST connector, or an XT60 connector, etc. And here we have a JST connector for the 430 milliamp hour battery and an XT60 connector for the 5000 milliamp hour battery. And these connectors are known as the main connectors and are what get connected to your ESCs and what you use to charge your battery and to power all of the components on your drone. And the thinner wires with the white connector on the end are also called the balance connector. And here each separate lead coming from each cell is coming from each cell, and the number of leads going into your balance connector depends upon the number of cells your battery has. So for example, the 2-cell 430 milliamp hour battery has 3 leads going into its balance connector, 1 for each cell, and the black lead is the negative lead. And the 5000 milliamp hour battery has 4 leads going into its balance connector, and once again you'll see the black lead, which is the negative lead. And a 4-cell battery will have 5 leads going into the balance connector. A 5-cell battery will have 6 leads going into the balance connector, etc. So to balance charge your battery, you are going to need a charger with a balancing feature that is made to charge LiPo batteries, and some chargers may only come with a balance charge port and will simply perform the charging using the balance connector. Other chargers will come with ports for the main leads of the battery that will be used to charge the battery, and a balance port that is used to balance the cells using the balance connector on your battery. And usually a full charge for these LiPo batteries is considered to be 4.2 volts per cell, which is an overall voltage of 8.4 volts for the 2-cell battery and 12.6 volts for the 3-cell battery. And another way to charge your battery is just to perform a normal charge without using the balancing lead, the balancing connector, and just using the main lead. And this will charge all of the cells with the same amount of energy regardless of whether some cells were more charged or less charged at the start. So you will not end up with a balance charged. And it may take a few charges before your battery is rebalanced when using the normal charge method. And even though this is a viable option for charging, it is recommended to just balance charge your battery each time. And the last type of charging we are going to discuss is fast charge. So this will not fully charge your battery. It will charge your battery to approximately 95% of the battery's capacity, and it will complete charging in about 2/3 the amount of time it takes to perform a balance charge. And the fast charge saves you a little bit of time because it skips the balancing step, and the charger only looks at the overall voltage when charging for safety reasons. And it will charge the battery once again to approximately 95% because the battery may not have been perfectly balanced before charging. And this means you will get an almost fully charged battery in a shorter amount of time than if you perform a normal or balance charge. But once again, it is recommended to just spend a little bit of extra time and perform a balance charge to increase the longevity of your battery. Alright, so those are all of the different types of charging you may see when attempting to charge your LiPo batteries. So now we will demonstrate how to use the digital battery capacity and the low voltage alarm to check the overall voltage and the voltage of each individual cell of your battery. So for the digital battery capacity checker, you'll notice that it supports lithium polymer, lithium iron phosphate, lithium ion, nickel metal hydride, and nickel cadmium batteries. And to operate it, you simply need to plug the balance connector into the input pins used for the lithium batteries, which is over here. And the top pin is used for the black lead, which is once again the negative lead. And you'll notice that this battery checker can support up to LiPo batteries with 7 cells. So now we will connect our 2-cell battery into the battery checker. And when you plug it in, you'll hear a beep. And you'll notice that it will turn on and display various information such as the overall voltage of the battery, which in this case is 7.58 volts, and it will tell you the percentage that it's charged, which in this case is 31%. And if you hit the cell button, it will tell you the voltage of each individual cell. So here you see that it is 3.791 volts, and that cell is 31% charged. And if you hit it again, it will tell you that the other cell is 3.793 volts, and it is also 31% charged. And also, when we connected the battery, you'll notice that it recognized that it is indeed a LiPo battery. And you can also hit the mode button, so that will give you the total charge on the battery, which in this case is 7.58 volts again, and it's 31% charged. And if you hit it again, it will give you the maximum minus the minimum charge, and here that is 0. And this is the maximum charge for the cell and the minimum charge for the cell. And if you hit it again, it will show you what the maximum charge is, which is 3.791 volts. And if you hit it again, it will show you the minimum charge, which in this case is 3.791 volts, because both of these cells are equal. And when unplugging these connectors and plugging them in, be sure to grab them by the plastic housing, and that'll make sure that you're not pulling on the wires, because the wires can become loosened and can be even pulled out of the connector, which can short circuit the battery. So that's the 2-cell battery. Now if we use the 5000 milliamp hour battery and we connect that, you'll notice that we once again grab it by the plastic housing, plug the negative lead into the top, and this will give us 11.40 volts for the total charge, and it's 33% charged. And then if we hit the cell button, we see that the first cell is 3.804 volts, and it is 34% charged. And if you hit it again, you see that we'll get 3.801 volts, and it is also 34% charged. And if you hit it again, you'll get 3.799 volts, and that is 33% charged. And once again, it recognized that it is indeed a LiPo battery. And if you hit the mode button again, you'll see that it once again gives you the total voltage and the percentage that it's charged. And if you hit it again, it gives you the maximum minus the minimum charge for the cells, which in this case is 0.005 volts. And if you hit it again, it will give you the maximum, which is 3.804 volts. That's 34% charged. And then it'll give you the minimum, which is 3.799 volts, and that is 33% charged. Okay, so that is the digital battery capacity checker. And then we'll unplug it by grabbing the plastic housing here, which is being a little bit of a pain. Okay, there it goes. Okay, and also if you have a nickel cadmium or nickel metal hydride battery, you would simply plug the connector into the input pins used for the nickel cadmium or nickel metal hydride batteries, which is right up here. And this battery can support 4 to 7 cell nickel cadmium and nickel metal hydride batteries, and it has 3 pins. And the black lead or negative lead will get plugged into the top pin, and the red lead or positive lead will get plugged into the middle pin, and the other lead will get plugged into the bottom lead. And once again, that will give you the total voltage and the overall charge percentage for that battery. And now we're going to take a look at how to use the low voltage alarm, which we have right here. And this will support, let me get it in the frame. So this will support 1 cell up to 8 cell lithium polymer, lithium ion, lithium manganese, and lithium iron phosphate batteries with their cells connected in series. And the precision of the voltage detection should be within plus or minus 0. I believe 0.01 volts. And the individual cell voltage display ranges from 0.1 volts to 4.5 volts, and the overall voltage display ranges from 0.5 volts to 36 volts. And the low voltage alarm will sound, which involves a high-pitched beep, and the red LED light will turn on when a battery's cell falls below 3.3 volts, which is the preset value. And the preset value can be changed to a value within the range of 2.7 volts to 3.8 volts. And you can adjust the preset low voltage alarm value by using the push key on the top of the alarm, which is right up there if you can see it. And you can check your battery's voltage by plugging your battery's balance connector into the pins from left to right, where the leftmost pin is used for the black or negative lead of the connector. And if you look on the back of the low voltage alarm, like I did earlier, you will see a label for each pin and all of the information that we've discussed. So now we will connect our 2-cell battery. And when you connect it, you'll hear a beep, and then you'll see that it gave you the number of cells in your battery. And then let's see if I can show it to you. Okay, so that'll say all, which is the total voltage for this battery, 3.57. The first cell, which is 3.77, and then the second cell, which is 3.78 volts. And then we can just unplug this. It's again grabbing it by the plastic housing. And then we can plug in our 5,000 milliamp hour battery, and you'll hear the beep, and this will tell you that this is a 3-cell battery. And the overall voltage was 11.4 volts. The first cell voltage was set 3.78 volts, and then 3.79 volts for the second cell, and 3.82 volts for the third cell. And you'll see that it just cycles through these voltages. And then you can just simply unplug it by grabbing the plastic housing. Alright, so that's the charging rate you should use for your battery, the different types of charging, and how to use the digital battery capacity checker and the low voltage alarm. And if this video was helpful, be sure to comment, like, and subscribe. And in the next video, we will be going over how to use a 4-button charger to charge your LiPo batteries using the various charging methods we discussed in this video. And that's it for now. Thanks for watching, and we'll see you in the next video.